Okay. Hi. Hello again, everyone. I guess the clicker is there. It is. Thank you. Okay. Hello again, everyone. My name is Wilton Moy, coming from the South Coast Air Quality Management District and specifically the Air Quality Sensor Performance Evaluation Center. And so in this talk, I'm going to talk about our program, which we test out low-cost sensors, and then we publish freely available performance reports for consumers to get a better idea of how a sensor product performs so they can make a more informed purchasing decision. And, I really appreciate the talk that Dr. Hughes and James Nemo gave yesterday about Afri-SET. I'm really impressed with what they've achieved in just 1 year. This program is approaching 10 years old now. So it was really great to hear that, and we're happy to support them and advise them in their efforts to get a similar effort, but for the West African context and for this kind of climate and the pollution sources here. You saw that yesterday. Okay, so guidance and clarity for sensor technology and the data interpretation from sensors. And the way we do this is we do free sensor testing for manufacturers if it's commercially available. And we also publish free performance reports for the public to understand their response and behavior. What we don't do, which someone asked the question yesterday, is we don't rank, score, grade, or promote, or recommend, or certify sensors, at least not yet. But we just, that kind of gets us in some trouble sometimes when people ask us which one's the best, and we're not really allowed to say that. It's more like we give you the information and you make your own judgment for your particular project and the needs of that project. We also don't provide sensor calibration functions or corrections in our test reports. That is something that Afri-SET, I think, aims to do for the West African context. But for us, we don't do that just because, we know that there's many people around the world and in different regions who would look at these reports, and we don't want them taking our regression formula and then applying it to their environment, and it wouldn't really be applicable. Yeah. Okay. So the ones we test, they must be commercially available, low cost. We're kind of like on this threshold of about 2,000 US dollars per pollutant that the device would report. They have to be plug and play, not some build your own kit. Provide real-time measurements. So we're talking anywhere from, around 5-minute time resolution or less. And we currently we evaluate the criteria air pollutants, the PM, CO, ozone, NOx, and now we just recently started getting into testing VOC sensors. This is the current makeup of our team. That's my boss, Andrea Polidori. He started AQ-SPEC back in 2014 with a couple other employees. And now he's risen really high up in the ranks in the agency. I'm now the program supervisor of the program, and I've got 3 staff. I'd like to give a shout out to them, Barrett, Randy, and Michelle. And I have 3 more members joining next week, so I'm happy to onboard them soon. Here are the core components, or the main components of the program. In our name, it might sound like we only do, air quality sensors and evaluation, but there's a few other projects we're involved in. Like we have sensor networks that we've set up and we maintain and operate. There's a data management effort going on where we're trying to we want to make a central data repository for not only the regulatory grade instrument data that we're collecting at our, regulatory air monitoring stations, but also incorporating sensors that are putting out public data on the maps in our area, and then feeding that data in, and building a giant database. And another thing that would separate this kind of effort is also that we want to put in some quality control checks. So oftentimes when you're downloading sensor data from some of these public databases, it's just like the raw data, and you're not sure whether it has been, checked and corrected or adjusted. So that's another thing we want to do for this data management part. And also we do a lot of educational outreach. We do sessions with the community. We make resources for the community to help them understand how to use sensors better. And we do stuff like this, like presenting here. Okay, so, that text is small, but I'm sorry, but you are going to get this presentation later, so don't worry. And I know I spoke too fast in yesterday's, but you'll get that presentation too to review at your own pace. But where the AQ-SPEC program, where it fits in the landscape of sensors, I kind of like to think of it as, you've got your manufacturers that make the sensors, you've got your consumers who use them, and then I'd like to think that AQ-SPEC fits in as an intermediate group, where we provide an independent or a third party kind of look at these sensors, and we relay that information to the consumers to help make it more understandable for them. But we also relay feedback back to the manufacturers because our test reports say, if it's not doing so well in our tests, maybe that helps the manufacturers improve the next round of their product. And I think the intersection of these three, parties in this landscape of sensors really, leads to our kind of optimal sensor understanding and continual improvement of this technology. One thing that we do a lot is we develop sensor testing protocols. So, near the beginning of when this program started, we have our field testing protocol and our lab sensor testing protocol. They've been used for a long time now. In 2020, we developed a mobile testing protocol. So how we're going to test sensors if they're going to be used on a vehicle. Last year, we published our VOC lab testing protocol because VOC sensors are now the hot thing. And we're also working on a field component of testing VOC sensors. And in the future, I would like to get a testing protocol out about how we would test sensors that are specifically designed for being used in a network. Because it's one thing to test like a standalone sensor that's intended to be used, by a single person and looked at by itself. But it's kind of a different thing when there are sensor products that are designed to be used in a network. Let's say like Clarity, for example, that's specifically geared for, sensor network use. And the kinds of tests and performance metrics you want to apply to those might be different than what you would apply for a standalone sensor. And we've also been contributors to a couple other sensor test methods. So ASTM, the American Standards, anyways, it's called ASTM International now, but it's kind of like ISO, but the American version, but now they're called ASTM International. So they're actually also like ISO. We contributed substantially to a standard test method for testing PM 2.5 sensors for indoor air applications. And also we've worked with the US EPA for their fine particulate and ozone air sensor performance testing protocol that they released a couple years ago. Okay, so at AQ-SPEC, we're very fortunate to have the kind of resources and infrastructure for testing sensors. We do field testing, so we have access to our agency's air monitoring sites that are fully equipped with all kinds of reference monitors. And we also have shelters for sensors for the ones that are not designed to be weatherproofed. We also have our laboratory resources. We have 2 environmental test chambers. They also have their full suites of reference monitors, and the chambers are able to control the climatic conditions, pollutant concentrations, and also they can do automated test sequence capabilities. And then one of our newer efforts is mobile testing, where we've kind of gutted a car and we put in reference monitors in there. And then so you drive around and you make measurements with the reference monitors, and you also mount the sensors on the vehicle. And then you can compare, how well do the sensors do when they're on a vehicle versus how much more does the mobile use of them kind of degrade their performance, because now you have the effects of like wind and turbulence that is it's probably not good for a lot of the PM sensors for their accuracy. And this is what you see in the picture, that's our 3rd generation. We've actually, when I first started the program, my first project was actually work on a Ford Escape version of this. So it was like a kind of a crossover SUV. So we had a little bit more room. And then our next iteration was a Google Street View Hyundai Santa Fe. So that had, special restrictions on the roof because they have their Google Street View camera. So we couldn't do anything to interfere with that. And then our current iteration of a mobile testing platform is this Chevy Volt. So it's a sedan, and it's a lot tighter and more challenging, but, I think it's a positive step for us because, maybe this is a more relatable kind of vehicle form factor for like community scientists if they want to do mobile air monitoring. And also we like to challenge ourselves with a smaller vehicle to fit all this stuff in. Okay, so in our sensor testing process, we kind of have this general flow chart that we go through. We do sensor scouting. So we reach out to vendors. We try to find new sensors that come on the market to bring in for testing. And then we acquire them. And then we do the actual sensor testing. And then after that, there's the data analysis. So there's some, QA, QC checking of the reference data and the sensor data, maybe some time alignment, some time averaging, and then statistical metrics calculations. And then finally, we can publish these reports that are publicly posted on our website. And sometimes we kind of aggregate these results and write them into journal publications as well. So for sensor scouting, there's various ways that sensors end up in our hands. We often look online, see what's new on Amazon. Sometimes a manufacturer will come to us because they already know our name. And sometimes they say like they can't get government contracts because the agency is saying, have you been AQ-SPEC tested? So then that's when they come out to reach out to us for testing. Sometimes a community organization or community scientists, they want to use a particular sensor for their project. And so they want to see if we've tested it or they recommend for us to test the product. Sometimes it comes from schools and students and teachers, conferences and workshops, sometimes university groups. A lot of academics are starting to use low-cost sensors, so they also reach out to us to see if we've done testing as well. And also for other government agencies, EPA, let's see what else, US Forest Service, they're getting more interested in the carbon monoxide sensors for remote monitoring for wildfire events. So we'll get other agencies also reaching out to us to ask us if we've tested, XYZ sensor yet. Typically, when we get our sensors, we'll meet with the vendors and manufacturers to determine their eligibility for the evaluation. I think most importantly, is it commercially available, like widely? Can a regular person buy it? And then we will bench test the units to ensure that they function at a nominal level. And if we don't see issues come up, then we can go ahead and deploy them for their evaluation. So for field testing, I'm going to go through like each way that we test sensors. So for field testing, that exposes sensors to real world conditions, to a complex atmosphere. And so we test them in triplicate at one of our air monitoring stations with the regulatory grade reference monitors. So on the left picture, that's kind of one of our air monitoring sites. And so there's a lot of rooftop railings that we can mount sensors to that are very close to the sampling probes for the reference monitors. And then here's also a Stevenson shelter, which is just a louvered, vented shelter for, these cute little ones they're probably more intended for like indoor use. So they're not sufficiently weatherproof designed. So we put them in here to protect them in case it rains or something, which we don't get a lot of. Okay, I said that. Okay, so we run our tests for 8 weeks, and Afri-SET, they're going to do this for 12 weeks because, just different environmental context, with the harmattan and the different dry and the rainy seasons. And the different metrics that we report are data recovery, intra-model variability, and then the different time averages, their correlations, and their errors, which James showed a very good presentation on some of these metrics yesterday. These are the reference monitors that we have available at our field testing site. So whenever 3 of them work, we have 3 PM 2.5 and 10 reference monitors, the Teledyne T640, GRIM EDM180, and a MET1 BAM 1020. We've also got an ozone, CO, and a NOx reference monitor. So that allows us to test particles and gas sensors and multi-pollutant sensors also. And I'm going to just walk through what a typical AQ-SPEC field evaluation sensor test report looks like. So you'll see a cover page, tells you the make and the model. You'll see like a background of how the evaluation was done. Like we'll tell you the date that we did the evaluation. Some manufacturer provided information about the product, and then some information about the reference monitors that we used to compare the sensor against which to compare the sensor. And then, you'll just see slides that show you the, data recovery metrics, the intramodel variability. We'll also, because if we have multiple reference monitors that report the same pollutant, we'll also provide a comparison of the 2 reference monitors. I think there was a question yesterday about, if you have a reference PM monitor that you're judging sensors against, how do you know that maybe the reference monitor is not behaving well? And so there's an unfair, judgment against the sensor in case the reference monitor is not doing well. So a nice thing is that we do have multiple PM 2.5 and PM 10 reference monitors. So it's always nice for us to provide in the report a comparison between like the GRIM and then the T640, for example. So that way, we have more confidence that we're not unfairly, penalizing a sensor because maybe our reference monitors are not performing correctly. So here's an example of a 1-hour time average comparison from a sensor versus a reference monitor. So, time series, scatter plots for each of the triplicates against the reference monitor.